Alright everybody, welcome to another update. This is another survey weather update. Last time we did a 5% risk. The first time we did a little bit of a risk analysis breakdown. That one didn't go all to in fruition, but this time we have a much more significant survey weather, which I'm going to discuss. And we're going to go through like the SPC forecast and then go through the numerical NAM 3 kilometers model. It's a medium range model and does kind of well and also in the short range. And we're going to use that and probably the HRRR, which is a short range. It shows like the sort of simulated radar for what would happen at that significant period of time during the survey weather event. And yeah, we're going to discuss forecast soundings and look at a little bit of the background entire global environment, like setup to like this sort of season and the sort of thing, because we're seeing early season. It still is the Dixie Alley season, so this does validate pretty confidently. And it's definitely a significant threat. It does kind of remind me of like March 2021 and like a bit like March 2023 where we had like rolling fork, but again a different type of setup. And even like last year's December kind of reminds me of that. But with this setup, we have an enhanced risk that has been upgraded now, and we clearly have it from the tip of northeastern Louisiana here into the southern Mississippi and southern Alabama, stretching through the central Alabama region as well. With this, we also even have a 10% tornado risk, and we have it hatched, which is the rain zone where at 25 miles of any given point within this, there's 10% chance of tornado forming, which is a very high probability for such a small given area. So yeah, the very significant chance of an EF2 type tornado to occur in that region, the 10% with the hatch particularly suggesting. So that is that. And then we have a 30% unhatched wind risk, which could become hatched, because the likelihood is, I mean, often with these severe setups in the southeast, you have very significant thunderstorms that congregate and become high wind producers as well. So likely we could see an upgrade to that, and we don't really have much of a hail threat. It looks like the shear is going to be very important in providing the tornado threat, but then it's going to take away and reduce the hail threat by increasing that upper level shear that we're going to be seeing. Alright, with the SPC forecast now. So clearly the summary is talking about the scattered gusts, damaging gusts. So this is potentially a likelihood that we could see that upgrade to hatched 30% of the wind risk. And so we've got a lower Mississippi Valley into the southeast. So lead shortwave trough continues to progress across East Texas, whilst the broad parent upper troughing shifts eastward through the southern high plains. Associated warm air advection is contributing to an expansive area of precipitation for the Texas Hill Country through the lower Mississippi Valley and the lower southeast, which is the area which is highlighted. Modified Gulf moisture, and we'll be discussing that. Modified Gulf moisture has been slow to return northward ahead of the system, and much of ongoing showers and thunderstorms are displaced well north of the warm front. Recent service analysis places a low along this warm extending along warm front near the Seattle vicinity in southeast Texas, with the front extending southwestward from this low through the lower Texas coastal plain and eastward into the central Gulf Coast. The 64-degree Fahrenheit isotherm currently delineates this warm front wall well. I can't speak. And then we have this environment. So now we're going to look at this. So the dew points and then it's going to mention a couple of things. And it says here, including tornadoes possible, and this convective inhibition is something we would also be discussing. And this is going to persist over time. And the strength of these storms will be modulated by the coverage of the preceding storms. And so reducing the buoyancy. When it reduces the buoyancy, you have a decrease in the Cape value overall, and the mixed layer of Cape value specifically will go down, and that's very important to see if it will reach even that 800 joules per kilogram threshold to allow for that buoyancy to increase, to allow for convective initiation. And if you have this preceding afternoon just cloud cover, it will reduce that buoyancy and thus reduce the overall ML Cape. Okay, and then we also have this potent line embedded QLCS tornadoes, which is obviously very significant in the southeast, happens a lot. Can be terrain enhanced, and also can be enhanced by the type of environment that naturally comes across when it happens. You have these mature troughs, you have like very linear type setups often that congregate into this giant line, QLCS, and then those often produce those tornadoes in these high shear environments. So you get to see a high, like a distribution numerical value of tornadoes. So last year we saw about 100 tornadoes, 108 tornadoes from that single outbreak, and that is the perfect example of this description. So this is going to be very important because this also will contribute to most of the tornado count that will happen. Alright, so this is the actual, so this is what we're looking at. This is currently looking at the 0Z of Thursday. So this is a prime environment, so basically the peak environment. And as we're seeing here, this is going to be the isotherm line, the pressure lines even actually. And we're going to see the temperature, and this is the temperature line. So clearly you've got the cold, we've got the cold on the backside, so that's going to be the troughing. And then the short waves are going to be the little kinks in this that will eject across, and we're going to see that this oval like feature here progress, and you can see the line progressing across. So this is the surface low pattern. Now we're going to see this north-eastward progression of a surface low. This surface low essentially is an extratropical cyclone that's going to be pushing across. This line here, where you see northwesterlies and then you see southwesterlies, this is the area where the cold front is defined, and also with this temperature difference as well. And then the warm front, which is currently in this forecast of this particular NAM 3 km model, predicting that it will advance from here in 21Z to up here in 0Z. So now what we're seeing is the difference between the previous model runs, where we were seeing a little bit of a southern extent, and now we're seeing more of a northern extent. So that increases the sphere capacity, the range, and allowing for a wider sphere, like a zone where the severe threat can undergo. And that's why we have the larger 10% region, and this also increases the overall likelihood of the threat to persist for longer as well, when you have that larger real estate type of larger real estate. Okay, the dew points follows very nicely in the same pattern actually, and here we can actually see, so this is in the prime environment time, so we can clearly see this here, with the cold front pushing through, quite progressive. You can clearly see several hundred miles lost within each time frame, so clearly a progressive on this side. So this is where the QLCS feature will appear. So when this progression pushes across, you're pushing cells into each other, and these cells will merge into a more of a linear type segment because they do not have enough time to separate and isolate to form supercellular structures. And there can be supercellular embedded inside this called QLCS. But often when you have these wind vectors pushing into each other parallel to this line that's going to be pushing across, they all bump into each other essentially, like a train type. Like you can see that it's just going to be passaging all the way across, pushing into each other, creates a giant line, and that QLCS is where the embedded QLCS tornadoes will occur. And this is where the large number of these tornadoes could actually occur. So this is going to be that region. It's a fairly moisture-rich environment, actually looking at about 64, 65 dew points, even 67 here. But we can see the larger this is the more significant threat where the strongest tornadoes could potentially occur. Now you've got a wide region of 70s and some 69, 68, and pushing all the way up northwards now on the northward extent. This is what's called like the expansion of the severe zone, and also this is what's increasing the likelihood of an upgrade of a severe threat. And some people are discussing a likely 15% type of severe tornado risk because of this sort of northward expansion, because it contributes quite significantly to the overall outcome of the outbreak itself. And yeah, it sort of expands very wide as well, from all the way out here, all the way down here, so we've got a very wide range as well. Okay, so now we're going to take a couple of soundings, and we're going to go from here, probably here, and maybe here. We can go. We probably look at 3Z as well, but I think that we can look at this first before we go 3Z. All right, prime environment. Let's kind of see what's showing up at the moment. Okay, so this is the current sounding we're looking at, and just looking at this. Okay, so this is like looking at Louisiana. Near the severe weather risk, and we're going to be looking at a pretty good profile actually. So we're looking at this instability, we're looking at mixed layer Cape values of 1700, so much more above. So we're looking at a moderate range rather than a minimal slight range. for instability, clearly showing in the mid levels this large amount of CAPE in this region. So you got the thermal line, the ISO, the ISO line, and then you've got the difference between them, and that sort of separation value in this middle level between the 500 millibars is going to be the significant mid-level mixed layer CAPE values as well. And then this lowest level here is the 3 kilometer, and even that can be described with 96 joules per kilogram, almost double what the requirement usually is. We've got a bit of this dry slot feature here, so we've got this dry slot potentially is like the predecessor, so it's like kind of shown before, a bit of that sin, but that's been worn off. This probably contributed to an inversion before, and now it's going to be pushing out. So actually, we might be able to find it. It doesn't really show any sign of like a significant convective inhibition. Now that is something to consider, because if there is not much, then that would basically mean that when you have a little of this, then you're having less inhibition on the air particles to rise, and so you're getting a high distribution and amount of convective initiation now, because you've got a bunch of storms that are not being inhibited, and the buoyant and these buoyant particles, air particles, are able to rise, and numerous are able to rise. So we're going to see a large amount of convective initiation, and that could allow for a lot of competition between storms. That could be a disruption and decrease the severe threat, but also sometimes, depending on the environment and like the environment ahead of like in the main warm sector, you can see a lot of mergers happen that can be useful to produce more significant tornadoes. So with that is something to be to keep in mind of. So this is also like a bias in models. So you got this little bit of saturation, and you got this low value. The values can be pushing out ahead, like probably the higher 70s for the dew point, and etc. for the temperature is also being around like 79 or something. So that is usually a bias. I can't confirm that like what the increase would actually be, but there is that bias that happens. And then you got a little bit of upper level saturation, which could also mean that it could have a high cloud cover that could kind of be persisting through the day. And now, with the wind profile we're going to be looking at, clearly we're looking at a lot of this. So we're looking at southwesterlies, and then we're seeing pretty good westerlies that kind of persist a little bit of a change in direction again, and then it persists in the upper levels. So we're going to see between the 1,000 and 700 millibars good directional shear that is represented in this hodograph, and then we have the increase in speed shear mainly between the mid levels actually and the 700 millibars. You've got this weird sort of backing that's kind of occurring here and in the upper levels, but this might just be a sort of forecasting error like by the model itself. But like if it does happen, then you've got a little bit of ventilation potentially in that low level as well. But like I think that this is the main thing. So you got the increase in the values from like 5 knots to like 40-50 knots of shear, and you got 44 effective in the bulk shear value. So that's going to be representative of that, and we're going to see that means that there's enough allowing supercellular convective initiation. Potential hazard type is tornado, so that is clearly confirmed. And we're going to see that this sort of venting out, the outflow out here in the 50-60 knots range, means that you're going to have pretty good ventilation as long as something like this doesn't happen. I don't know, but this should allow for that ventilation to allow for the precipitation to be ahead, allow for visibility if you're observing the storm, and also could allow for persistent growth and maintenance of updrafts without them dying off so quickly. So you might not see as much cyclic mesocyclogenesis, and you can see a single long track supercellular type threat. Lots of long track tornadoes essentially would be a risk. And with these sort of hodographs, often when you have like SRHs of 328 effective inflow there, so now you're looking here, you're looking at a large supercell. Now these large supercells in a long tracked environment can be primed to produce like large type tornadoes, and these large tornadoes obviously the vortex dynamics are not really going to be understood from a single holograph sounding, but normally when you get a significant violent tornadoes, now that word basically just contributes to the, like a large type tornado, so a wedge type tornado, or any sort of other type of tornado that is going to be strengthening, persisting, and able to recondensate even during weakening stages, and then maintain that intensity, like a very high end intensity, for a long period of time, if the environment, the primed environment, is able to produce that tornado in the first place. And based on what we're seeing with this sort of instability and allowing for these sort of holographs, that's showing that there's a high probability for that to happen, and that means that we could actually see that be observed. So that is something to be watching out for. And I think that this just, it just demonstrates the same thing in all the other soundings, because we're looking now in the 10% hatched region in lower Mississippi, and this is essentially the same thing. We've got now a PDS tornado, so this also doesn't have that weird sort of backing, so there might have been a little bit of forecasting, the model error. We're seeing this part of the holograph maintaining the curvature, so there's a veering within this part of the height. We have a little bit of backing as well, so that good ventilation. I mean, you have 400 meters squared per second squared in this sounding as well, so clearly, even with instability, so you've got a lot of ways to rotate that vorticity in the lowest levels. Now, when you have a lot of vorticity stretching in the lowest levels, you break that shear layer in the lowest levels for these vortexes to grow. So now when you see these condensation funnels, they're able to persist and strengthen, condensate into a very large mass on the surface layer, and that allows for large tornadoes to form. Often when you don't see that, like a lot of vorticity stretching the surface, you see this very weak sort of cone-shaped tornadoes, and that is mainly due to that the lack of that compensation, and also that significant shear layer breaking it apart, and that dry air in the lowest levels not allowing for it to push through and allow for condensation of tornadoes. Now, this is clearly a prime sounding, so this could be upgraded to a moderate risk with something like this. And the same is here, and in fact it increases in every way. In fact, the bulk, so if we have bulk shear of 60 knots, now we're looking at pretty significant values. And one of the things that can be of concern, like for the updraft itself when it grows into its prime environment, now we're looking into western Alabama. So if we have this, say we have these systems persist, and now they're growing and they're persisting into western Alabama, they're going to be facing very high shear environments. Now, they're fully exposed and still maturing. They're not even in the they haven't matured to their full capacity in the size. We can see them be breaking apart and falling apart because of the high shear environment. Now, what you need to prevent like these supercells from breaking apart in that environment is an upscale growth. Upscale growth is now when you're going to have a bunch of cells, supercells, that are running into each other, conglomerating to form a line sort of complex or supercellular complex, and they can now compensate for that high shear and protect the supercell, and essentially give it cover so it can grow and mature and then become a healthy updraft. And that is important because that can actually happen. Like, we could see a bunch of maturing like bean-like structures, but they all could fall apart. But if we see some upscale growth, that would prevent that from happening. There are other situations where they can also grow and persist. I mean, if you have mature, healthy, long-track supercells anyways, from existing from eastern Louisiana and running all the way through western Alabama, you've got now a single supercell that's mature enough to resist that sort of high shear anyways. Or everybody, I just forgot to mention the HRRR in this update. So here it is. And there's a couple of other things I forgot, but this is just the most important part that I want to show, was the HRRR. So it's a high resolution short range model, and so we're just going to discuss this a little bit. Currently, around this time, there are a couple of severe storms in East Texas and in northern Louisiana. A lot of precipitation. This precipitation index probably suggests at least a slight risk or above, probably because of the trailing amount of cells and multi-cells that will go over the eastern Louisiana, central southern Mississippi, and central and southern Alabama. So we're going to have that as a risk. But the main thing is, this also acts as a cloud cover, so this may actually reduce instability values if we see it persist. We do see a clearing by 15Z, so it's not unlikely, maybe a little bit to the northern extent where the warm front is maximized at the northern extent. That's where it could be tampered with this still remaining in place. But then we see some convective initiation on the western side, and then we see this this QLCS really. This is the main part that's beginning to form, and then we start to see this, and then we start to see some early signs of some supercellular convection at or head of the front, and really some of the embedded supercells can also occur here. Prefrontal supercells, so this probably isn't like a confluence band. It's probably like a subtle southwesterly and a southerly component that creates a convergence. You create some of these little cells that are appearing, and let's just look through later. So we do see eventually by 22Z, that's the maximization. So we start seeing a lot more of those supercells, and really they do persist. They come quite wide scale, but you start seeing some of these long track ones that appear with these dense cores, high reflectivity. This is simulated radar, so this is actually like what could happen. And so again, this is very possible, and we even have some embedded supercells shown here. So all in all, we do see what the sounding suggested is essentially what's coming to fruition. We still also do see like a lot of these small cells get shared apart, and then we see the front. It doesn't really catch up much at all, but we do see a persistence of a lot of supercells. So that's the main concern, and we really could see that come into fruition. Alright, with this I will continue with the rest of the video, and I think that's most of the things I was going to say. So with the last thing is this sort of environment diagnostic. So with the environmental diagnostic that we're looking at for this season, so we've got Reed Timmer, which I really like this graph, because it's obviously it's one of the few graphs that are very clear and demonstrative of the 2025 season sort of anomaly diagram. So we can clearly see this type of environmental pattern. So we've got this La Nina emerging. Technically, it is a La Nina, what's called upwelling in the Peru region, but the Nina 3.4 is still warming, and you still got this warm surge here, and you got the equatorial Pacific with the cold anomalies, and you got this cold type of pattern here in the eastern Pacific, and then you've got this warm sort of pattern. So you've got these different oscillations. El Nino is obviously the most significant oscillation, but you have the PDO, the NPO, and then you also have the Western Pacific oscillations as well, and some North Atlantic oscillations. But then the main thing here I just want to bring about, without explaining it, like overly explaining it, is this is 2011, and now this obviously, like, we're looking at a very similar type of pattern, and almost like identical in most ways, except that you do have a little bit of a stronger PDO type, at least from the graphics demonstrating, but almost everything else is dissimilar. And except also you have now a warmer Gulf of Mexico in the 2025 season. So now you've got this rich abundance of moisture that's able to be shunted upwards into the warm sector, and you've got a very similar type of environmental diagnostic. Doesn't mean this will come absolutely into fruition, not necessarily, but what we're seeing is that based on the environmental diagnostics, you've got a very similar type of oscillation and sea surface temperature pattern, which is like 2011, which is obviously the most infamous, one of the most infamous seasons of all time. And one of the things also that I just wanted to mention, that just like sort of an interesting fact that I kind of learned myself, was that you have this sort of like emerging La Nina type feature, but this emergence and the way it's not been like pronounced so much as like 2011, where you can clearly see the La Nina cold pool, like at least more of the cold pool around this area. You got a little bit of this warm surge, but one of the things is because of the solar cycle patterns. And I learned that if you have a solar cycle pattern and you have a post-maximum cycle, you can have actually more of a delay in that La Nina to emerge and pronounce itself, and you can have this neutral type of Enzo pattern. And what that also sometimes might mean is that sometimes when you have these you have these characteristics that are emerging, you have a general sort of weather pattern, you have less of a focused weather pattern. So that necessarily doesn't mean that the 2011 will be absolutely demonstrative of what the 25 season will be. But sometimes with a post maximum and in a La Nina, you can have more of a generalized pattern, and so you might see a little bit of like 2011 type situation, and then you've got a bit of a generalized pattern following that as well. So the distribution may not be the same, and that might be true. We obviously yet to see, but like Dixie Alley in 2011 was very pronounced, and now we're seeing a very pronounced Dixie Alley like type of pattern, at least coming in the future, because not just today, if you look at the convective outlooks, you do have a Dixie Alley type of pattern here. You've got here day 4 enhanced risk already, and often, I mean, day 4 enhanced risks are extremely rare, especially even in Dixie Alley season. Usually when that happens, you almost like, so you get the enhanced risk, and sometimes you get in moderate or even a high risk. So clearly a pronounced Dixie Alley season, and we are yet to see what will happen in the future. I still got more research to kind of like do to be able to explain this and understand this, but the best of my knowledge I'm trying to explain to, and if there is any sort of thing that I did not mention correctly, then you can correct me or tell me about that as well. So I think I've explained most of the things, and we should see how this event comes into fruition. If there is anything that does come into fruition, any of the updates, like I did yesterday actually, I did yesterday I did update on the tornado that did happen in Sunbright, Tennessee, the EF2, that was very damaging. And so normally when I do this is a post-analysis breakdown of the tornado itself, because obviously you can't forecast the tornado itself that will happen, so you can do a breakdown after it's happened and learn about what's happened. And so I will continue to do any of these updates if anything does come into fruition from this outbreak. It does look very favourable, so if there is anything, again, I will explain that in a short or something, and any other requests I will try to consider as well. So with that, I think I'll see you guys in the next update.